Please join me in welcoming the CMU team.
Hi everyone, I'm Manya, this is Leah and Manjari, and our fourth team member Hannah couldn't be here today, but you'll see her in a bit in the video. So before we get started, how many of you think cars today are really complex? And now, how many of you would actually try to fix your car yourself? So that's why most of us need mechanics. We need to train the next generation of automotive technicians to make sure that they're well equipped to tackle the challenges of today and tomorrow. So we've been working closely with a vocational school in Pittsburgh, Rosedale Technical College. And here we met Alex and Jesse. Jesse's an automotive student. He loves cars, and he can't wait to get out into the world and get a job at a dealership. His instructor, Alex, she loves keeping up with technology in cars and wants her students to be problem solvers. But both of them have a few challenges in common. The first is the complexity of automotive repair. Not only do they have to juggle disparate sources of information, but they also have to do this while being immersed in the multisensory experience of their work. The second is the technological advancement that's embedded in their cars, as well as the tools they use in the workshop. So this means that Jesse and Alex are always being pushed out of their comfort zone. And finally, it's about staying relevant. So making sure that Jesse and Alex can always stay up to date with the latest technological advances and making sure that they're not replaced by technology. And so we've been talking to a lot of people, like instructors, students, car enthusiasts, tech experts, to really get a feel for this space. We've also spent a lot of time in vocational schools, so much so that we felt like we were students there ourselves. And finally, prototyping played a really big role. From low to high fidelity prototypes, we even got some mechanics students involved to create some cool stuff with Lego and Velcro and Play-Doh and that kind of stuff. And all of this, for us, was really powerful in helping us design with our end users rather than for them.
Our design principles represent some of the insights we unearthed in our research. They help us to make these insights actionable. First, our design needs to support physical learning. This aligns with our take on the design brief, which emphasizes the potential of mixed reality to extend out of traditional screens and into the physical world. Secondly, students like Jesse need to be more than traditional mechanics. Changes in technology require our system to train students to be lifelong learners who are flexible and relevant. Our system also needs to support people in doing what they do best, problem solving. Human judgment will always be valuable in the industry, which cannot be simply replaced by technology. Finally, in today's world, a car manual just isn't enough for either mechanics or students. We need to integrate information and media to provide Jesse a seamless learning experience. Now presenting Dash.
As automotive technology becomes increasingly complex, so does the training required to repair it. From electric engines, to connected cars, to autonomous transportation. There's just so much to learn. That's where Dash can help. Dash is an educational platform that integrates contextually relevant information into dynamic mixed reality environments that promote critical problem solving and data-driven learning in automotive repair. To really understand how Dash is driving the future of automotive training, let's meet some of its users. Dash is a game changer for veteran instructors like Alex. The platform lets her build practical lessons around work orders and link relevant material like diagrams, schematics, and instructional videos for easy access in the workshop. For students like Jesse, Dash brings theory and practice together in meaningful ways. Jesse can engage with abstract concepts via interactive lessons and dive into the details of how things really work. In the shop, he has everything he needs to work through complex problems. He can access sensor data via the internet-enabled scan tool, view schematics in context, and customize his dashboard to support his unique learning needs. He can even pull Alex in for help if he needs guidance. Alex can review Jessie's work remotely, make note of anything she wants to discuss, and even save teachable moments to share with the rest of her class. Interactive lessons, augmented training, and streamlined collaboration. This is how Dash seamlessly integrates practice and theory to empower 21st century automotive technicians. Dash, driving the future of automotive training.
From the video, we can see that the Dash system is composed of several main parts. A tablet backend to customize courses, and augmented reality safety glasses to view contextual information embedded into parts of the car, which also supports teamwork mode. Augmented reality glasses make sense in this context, since mechanics already wear safety goggles in workshop. Internet-enabled scan tool senses live data and sends it to AR glasses. Meanwhile, instructors can use tablets to review students' work. In the future, we also see the system interfacing with other IoT tools used by mechanics.
So the tablet interface lets instructors like Alex create courses, but also deep dive into the work history of the students to make sure that he can get targeted feedback to her students. This is really important, especially when dealing with large class sizes. With the IoT-enabled scan tool, the information is relayed directly to where the work is. The system can also scan and recognize certain physical components and give them information directly to the students through the AR goggles. We got to these features through extensive user testing and prototyping. In fact, one of our low-fidelity prototypes involved safety glasses as AR glasses, a little laser pointer to mimic gaze, and we layered our UI in front of a photograph to make sure to replicate the AR experience. This was great as a co-designing workspace and really helped us inform our system architecture. We also created small video prototypes to make sure that we can relay what it feels like to work in augmented reality to the students and faculty at Rosedale. This was a great conversation starter in learning the needs and preferences of these people. What came out was a hybrid workspace that existed in the part physical and part digital world. The AR menu lets students access information and relay directly into a space, but they can also tag and share information with their instructors. The contextual menu was created so that students can navigate easily through information on certain components rather than having to go through the main work dashboard to access information. Their customizable dashboard allows them to have critical information at hand whenever possible. We understood the complexity of fieldwork, and we understood that each interaction has a different context specific. So what would a student do if they're working under a car? What about when they have many tools in their hands? We recognize that voice, gaze, touch, gesture, all of these interactions have a very important notion in this field, and that's why mixed reality is so apt for this.
I know this doesn't exist yet, but I can already see it making my life so much easier. So this was a quote from one of the students we worked with. And so with Dash, we really hope to support students like Jesse even after he leaves school so that he can keep up with challenges and changes in the industry. For Alex, we see Dash being able to give her greater visibility of her students and their work. And for all of you, well, your car is probably the most expensive computer that you're going to buy. So we want to make sure that your mechanics are ready for the challenge. And so we've just given you a glimpse of our deep dive into automotive repair. But we also see applications for something like Dash in related fields like maritime or shipping maintenance. So that's it from us. A special thanks to Rosedale, and thanks to Microsoft for having us here.
Thank you. Panel, who would like to start? Andy.
Thanks for that presentation. It's really nice. You know, AR has always been thought of as a great tool for engine repair. Some of the very earliest examples that I've seen are about engine repair and other technical fields. And it's a nice domain because you know a lot about the thing you're looking at, right? So you might even have the CAD models and schematics. But I wanted to ask you a different question about related to the novelty of the technology. You did a really nice job of interviewing a bunch of people, a bunch of, I guess, mechanics or student mechanics. And how do you deal with the phenomenon that people will naturally sort of get excited about novel technology when it may not actually be in their best interest, right? How do you get over that hump when you show these kinds of technologies to these people?
Thank you. That's a great question. So we actually witnessed that while we were working with these people. It was very interesting that every time we spoke about augmented reality or mixed reality, their immediate reaction would be like, I don't want it to replace me. I don't want to replace my job and my vocation. So while we worked, we also had to make sure that the technology we create and the phenomena we're showing them helps them become better rather than replace them. And I think that's what we really aim to work at with the tools. So the technology wasn't telling the students what to do when on a car, but really assisting them so that they can problem solve themselves. If that answers.
Well, that's a rather different question. I guess what I was concerned with was I can see the students becoming excited about it because it's a new shiny thing. You know, maybe they heard a bit about HoloLens and that kind of thing. I guess what you're saying is that there was actually a different effect, almost going the other direction. They're concerned that it's going to replace their or obviate the need for a mechanic. Yeah, okay, interesting. Thank you.
Thank you very much. This is certainly a practical application of mixed reality. I'm really curious, though, why you picked this particular one. Certainly there were quite a few out there. How did you go about selecting this particular application
I think
domain?
for us, it started off that we were trying to find a space where mixed reality could really make an impact. And we were just drawn towards the field of education. And with something like a vocational skill like automotive training, we felt like there was very real impact that it could have there. And I think that's what really drew us to it. We started off by looking at more kind of how do we make things like automotive repair okay for distance learning programs and things like that. But I think ultimately we settled on focusing on the vocational school because there was a lot of impact on the students that we could have there itself. So that's kind of where our focus came from.
We also looked at, I remember we broke down to a spectrum of physical learning environments, whereas theoretical learning environments, and tried to map out what mixed reality can do for each one of them. So what really enticed us with physical learning environments was the complexity involved. So you can't replace a car in a virtual reality environment because they still need to smell the oil and check the engine, shape the components. And how do you get technology not to be disruptive in that realm was kind of the challenge that we really liked.
Yeah, and we also look into if there is a business opportunity in this field. And during research, we found out the tool they are using currently are already very expensive, and they are using some kind of simulator to try truck drivers in the same college. So we think it can be a good fit in this field.
Have you thought about next steps? What would you do in terms of actually getting to someone who could help implement this, help you implement it in the field for real?
So when we actually spoke to Rosedale, they were so excited about it. They actually want to come in here, talk and see our presentation, talk with you guys, because they want this to be implemented. They can see the value of it. I think for us, we want to study a bit more on the interaction level of it. So how does each of the gestures, voice, touch, mix it in and make sure that the system works well for these students? But we haven't really thought of next steps after this, let's say.
One more question. Have you thought about how you can use your same technology for assessment? Determine how well the students have learned and how do you platform that so that there's something they aren't getting, so they go back and learn those things, perhaps.
So those were kind of moments that we thought that the students, once they're working on it, they get shared with the instructor on the tablet. The instructor can review them and actually save and share them with other students. But what was also interesting is when we spoke about an AI component, maybe studying them as they're working and giving them feedback as they're doing it, they weren't very perceptive to the fact that an AI would be telling me changes. They still wanted the human component of an instructor giving me feedback or a mentor almost to guide them. So that was actually a very cool fact that we found out through machine learning and AI, and kind of what they thought about it. Yeah.
Great. Thank you.
Thank you.
Thank you.
Rafik, are you fine? Because we're out of time. If you have a quick one. Yeah.
Got the answer. The last answer was perfect, the question, but really beautiful and a purposeful, again, project. And
Thank you.
repairing machines as humans, I think, is a very wonderful moment in the probably near future. We are still able to fix them.
Thank you.
Fantastic.
All right.
Thank you.
Thank you.
Thank you.